Let's start by reading out question 4.851's. A solution of 100 ml of 0.2 molar KOH is mixed with a solution of 200 ml of 0.15 molar nickel sulfate. Write the balanced reaction. What is the precipitate? What is the limiting reagent? How many grams of the precipitate form? And the question that we are going to address right here is what is the concentration of each ion that remains in solution? Now, I can't really solve question E in isolation. I have to write the balanced chemical reaction. So potassium hydroxide plus nickel sulfate is going to give me potassium sulfate K2SO4, and for lack of space I'm going to write nickel hydroxide here. Okay, now in order to balance this, all I have to do is to put a K2 here and we're done. Let's quickly also write the states of matter. All potassium salts are soluble, aqueous. Most sulfates are soluble, and nickel isn't one of the exceptions, so aqueous. All potassium salts are soluble, again aqueous, and nickel hydroxide is a solid because most hydroxides are precipitates if they're not salts of alkali metals. Okay. Now, when you're given in both cases right here, so let me change my color. Look at the blue box that I'm drawing right here. In both cases, you're given volume and molarity. And the minute you're given volume and molarity, what you're given is moles in disguise. Remember that volume times molarity is moles. If that volume is in milliliters, you're going to multiply and divide by 1,000 to get moles, okay? So that's, for KOH, that's going to be 100 times 0.2, which is 20. And if you divide by 1,000, that is 0.0200 moles. For nickel sulfate, the number of moles is 200 times 0.15 divided by 1,000 is 0.0300 moles. Okay. Now the question is, this suddenly becomes a limiting reagent question. You might have already solved this, but I need to do this in order to go ahead. In order to do limiting reagent stuff, what we're going to do is to find out how much potassium sulfate we're going to form from each. So basically 0.0200 moles of KOH is going to form how much? Let's see. Our molar ratio is 1 mole potassium sulfate to 2 moles KOH. Okay? And that tells me how many moles of potassium sulfate I'm forming. That's going to be 0.0100 moles potassium sulfate. Let's do the same thing for nickel sulfate. We start with 0.0300 moles of NiSO4. The mole ratio, however, at this time is a 1-to-1 ratio. We see from the coefficients that we have 1 mole of K2SO4 to 1 mole of nickel sulfate, which is now going to give me 0.0300 moles of nickel sulfate. That makes, so obviously it's pretty clear right now that the substance that gives you the lower number of moles of potassium sulfate is KOH right here. So KOH becomes the limiting reagent right away, and that is a big deal. This means that the amount of K2SO4 being created is going to be determined by KOH, not nickel sulfate, because it's a limiting reagent. I'm going to write that as in bold right here. And that is going to be, sorry, this was 0.02 and this was 0.0100 moles. Okay, so now remember that you have 0.03 moles of nickel sulfate. We also need to find out how much is reacted, okay? Because remember, the question is, what is the concentration of each ion that remains in solution? In order to write the concentration of each ion, let's first write it in a complete ionic equation form, okay? So I'm going to write it right here, and let me see if I can increase the thickness. Okay, here you go. So in red at the bottom of the page is going to be 2 KOH. Anything in aqueous breaks up into ions. Nickel sulfate is also aqueous and breaks up into ions. Potassium sulfate is also aqueous because it's soluble and breaks up into ions. However, nickel hydroxide is a solid and remains in its form right here. Okay, So now a limiting reagent is consumed completely. What that means is that the KOH is gone. That's the very definition of a limiting reagent. The Ni2 plus and the SO4 2 minus, some of it is remaining. We're going to have to calculate how much. All of the KOH has gone to this side as K plus. And we know we had 0.02 moles of KOH, so we must have 0.02 moles of K plus, okay? There is no OH minus remaining. All of that is a precipitate. So now the deal is how much sulfate. In fact, you can actually, we don't even have to calculate how much nickel sulfate is remaining, because some of the sulfate was unreacted and some of the sulfate was reacted and moved over to the other side. But in total, we had sulfate concentration, both of these together are going to be 0.03 moles. Okay, I'm not doing sig figs here. I should put a 00 here and a 00 here. Does that make sense? Because nickel sulfate was 0.03 moles. That sulfate didn't go anywhere. Some of it was unreacted, some of it was reacted. So in total, the sulfate concentration is 0.03. Now, the nickel concentration, however, right here, that we do not know. We're going to have to find out how much of the nickel sulfate was unreacted. Okay, let's find out. KOH is your limiting reagent, and we start with 0.02 molar. So let's do that. 0.02 molar KOH, and it was a 1:2 ratio, so we had 1 mole nickel sulfate to 2 moles KOH, and that's how you do your unit conversion with molar ratios. KOH cancelled, which means the amount of nickel sulfate that reacted with KOH was 0.0100 moles. Okay, how much did not react? You have to subtract what was, we had how much did not react would be 0.03 that we had initially minus 0.01. Okay, and so scrolling down, this would be reacted and you would have 0.0200 moles nickel sulfate remaining. Okay, this is only important because the stuff that the nickel that reacted became nickel hydroxide, so it's gone. The nickel that didn't react remained as nickel 2 plus. So if you scroll back up to the let's see if we can scroll back up right here. So this guy is going to be 0.0200 moles. Okay, now the question is the concentration of each ion. So you're going to take the number of moles of each of these guys, okay, and divide by the volume, and that volume is what was that? That volume is the sum of the two volumes, so that's going to be this guy right here, 100 mils and 200 mils. So your total volume, so let's scroll all the way down and write, total volume is 300 mils. Okay, take care of sig figs. I haven't done that for the sake of time here. So the concentration of K plus, for example, is going to be 0.0200 moles divided by 0.300 liters. And there might be more sig figs than that, okay? So that's going to be whatever number that is, 2/3 molar, okay? Not 2/3, but a little bit less than that. The concentration of OH minus, there is no concentration. The concentration of nickel 2 plus is actually going to be the same number, 0.02, as we've seen. So every time you scroll back up, the concentration of sulfate is going to be 0.03. The number of moles of sulfate remaining that were 0.0300 moles divided by the total volume, which is 0.300 liters. Okay, and I'm going to recap this whole problem one more time. Okay, in order for you solve this problem 4.85e to find the concentration of each ion, the first step was to let me get my pen back in order. The first step was to write a balanced equation. Okay, the second step was to convert moles times volume, molarity times volume to moles. Okay, molarity times volume was moles. Just be careful that volume is in liters. The third step was to find the limiting reagent, and the limiting reagent was found by finding who gives the least amount of the product. Choose any one product. Whoever gives the least amount of product is your limiting reagent. Okay, and the fourth step was to write the complete ionic equation. This was important because the question actually asked you how much of each ion was left, okay? At this point, you would know that the limiting reagent was completely used up. So this is used up. So using the limiting reagent, you would find how much of the products were formed. So you would say how many moles of products were formed. So remember that the substance that becomes a solid is not ions. So you wouldn't be measuring that, and you would then go back and measure every other ion that was formed. Hopefully this makes some sense. Post comments or write to me if it doesn't.